Hello children, welcome to aimsindia's online classes. In today's video, from physics subject, motion topic we are going to discuss. So these all topics already we have covered children, about scalars and vectors, examples, vector notation, types of vectors, distance, displacement, speed, velocity, change of velocity, acceleration, and about equations of motion already we have covered. Some problems we have discussed about graphs, distance time graph. Next, about velocity time graph already we have discussed. Next, about acceleration time graphs. This topic also already covered. And we have revised the CD of points in our previous video. Some of the concepts, definitions, formulae from this chapter. Now let's start practice sheet problems, children. So we have level 1, practice sheet 2. The question type is conceptual understanding type. Conceptual understanding type questions. So in that first question, it is like single correct answer type question, children. You will be given 4 options, and out of 4 options, 1 option will be the correct answer. The question is, vectors acting in the same plane are called. Vectors acting in the same plane are called. If they are acting in the same plane, they are called coplanar, means same plane. Coplanar vectors. So option C is correct. Next, question number 2. The acceleration of a body has the direction of what? The acceleration of a body has the direction of change of velocity, because acceleration is nothing but rate of change of velocity. So the direction of acceleration will be in the direction of change in velocity. Next. So change in velocity is a vector quantity, because velocity depends on displacement. The formula for velocity is displacement by time. As displacement is a vector, velocity is also a vector. So change in velocity is also a vector, because change in velocity means final velocity minus initial velocity, which are both vectors. So difference of 2 vectors also will be a vector. Next, 4th question. Which of the following has both magnitude and direction? Which of the following has both magnitude and direction? So the physical quantity having both magnitude and direction is vector. Scalar means it will be having only magnitude but no direction. Tensor means sometimes acts like scalar, sometimes acts like vector. It is neither scalar nor vector. So we have answer only vector. Next, 5th question. So acceleration is negative when? Means acceleration will be negative. Acceleration is negative means it is also called as deceleration, or we have another name, retardation. Deceleration or retardation. So this acceleration will be negative when velocity of a body decreases with time. When the velocity decreases, so at that time we can denote acceleration with negative sign. So B option is correct. Next, 6th question. The area under velocity time graph represents. So whenever we have a graph between 2 quantities, in every graph we will come across 2 words. One is slope, another one is area. Slope means y coordinate value into x coordinate value, we have to measurement of y coordinate by measurement of x coordinate. This ratio is called slope. Area means measurement of y coordinate into measurement of x coordinate. This product is called area. So here area means product of these two, product of velocity into time. Velocity into time, the product is equal to displacement, because velocity equal to displacement by time. So displacement equal to velocity into time, displacement, or it is also called as distance covered, displacement or distance covered. So option A is right. Next, if displacement time graph is parallel to time axis, then the body is, suppose these two are the coordinate axis, x-axis, y-axis and origin. On the y-axis, normally we take displacement. On the x-axis, suppose we have taken time. If the displacement time graph is parallel to x-axis, is parallel to time axis, means, so 0 to 1 second displacement is 4, 1 to 2 seconds displacement is 4, 2 to 3 seconds displacement is 4, means as the time passing on, but the displacement is not changing. Though the time is passing on, but the displacement is not changing, so the body is considered to be stationary. Next, so velocity time graph, same like previous example. Suppose if xy are the coordinate axis and O is the origin. On the y-axis we have taken velocity vector, on the x-axis we have taken time. If the velocity time graph is a straight line parallel to time axis, so after 1 second velocity is 10 meter per second, after 2 seconds velocity is 10, 3 seconds velocity is 10, 4 seconds velocity is 10. The time is passing on, but there is no change in velocity, means it is called uniform velocity. It is having velocity means the body is moving. We cannot tell that it is stationary, but it is moving. How it is moving? With uniform velocity it is moving. So option A is correct. Next, the distance time graph of a moving body is an ascending straight line. The distance time graph, x-axis, y-axis, origin. On y-axis displacement vector, on x-axis time scalar, and the distance vector, distance, not vector. They have given distance. Sometimes if it is in definite direction, it will be displacement, which is a vector. So here, distance time graph of a moving body is ascending straight line, means not parallel. It is ascending straight line, means at 1 second velocity is 5, at 2 seconds, distance is 5 meter, at 2 seconds distance 10 meter, after 3 seconds distance 15 meter, means in same intervals of time, same amount of distance is increasing. So distance increasing means distance by time, that ratio is same. In 1 second, 5 meter, 5 by 1 means 5 meter per second. In 1 second, its velocity. From 1 to 2 seconds, it has traveled from 5 to 10 meter. So again, 5 meters covered in 1 second time, 5 meter per second. So, and again 2 to 3 seconds, 1 second time, it has covered 10 to 15 meter. again 5 meter per second. Means in same amount of time, same amount of distance it is covering. So, but as they have given distance, the rate of change of distance, it is called speed. Here we can observe speed in the body, but the speed is uniform. In same interval of time, same amount of distance is changing. So it is uniform speed. The body is traveling with uniform speed. Next one, 10th question. The slope of displacement time graph represents. Already I have told children, slope means measurement of y coordinate by measurement of x coordinate. Here the y coordinate is displacement, measurement of displacement by measurement of time. Displacement by time is nothing but velocity. So, but here they have given uniform velocity. So, answer uniform velocity. If there is no uniform word, if there is velocity, that is also correct answer. Next year, we have another type of questions, single correct answer type questions. So, shortcut SCAT. Here also one question will be given. Under that you will be having 4 options. Out of 4 options, only one option will be correct. So, what is the question, children? A car initially at rest starts moving with an acceleration of 4 meter per second square. The time in which it picks up a velocity of 72 meter per second is. A car initially at rest, beginning at rest means initial velocity is 0, but acceleration is 4 meter per second square. The time value we have to find. In how much time it will pick up a velocity of 72 meter per second. Final velocity is 72 meter per second. So we have to find the time. So they have given u value, because it is at rest means initial velocity will be 0, and they have given a value, final velocity they have given, time we have to find. Because the body is moving with they have given one acceleration. So we have to assume it is uniform acceleration. So whenever the body is traveling with uniform acceleration, so we can apply equations of motion there. The relation between, we can apply equations of motion. Under equations of motion, the relation between these 4 quantities in the absence of displacement, is given by one formula, V equal to U plus AT. From that, as we have to find time, if we take AT, if we take U that side, it will become V minus U. If we take A that side, it will become V minus U by A. Let's substitute values, children. In the place of V, 72, in the place of U, 0, in the place of A, 4. 72 by 4, which is equal to 18 seconds. So option B is correct. Next, 12th. So given V equal to 0.6 minus 0.3t in SI units. So all quantities are in SI units. Then the initial velocity and acceleration of the body are. They have given one expression representing V, which is the final velocity. In that right hand side, we have an expression having time, but U, initial velocity and acceleration are missing. But from this equation, we have to find U and A. For all these questions, we have to assume, children, all these bodies are uniformly accelerated bodies. Uniformly accelerated bodies. So that we can apply equations of motion. So, given V equal to 0.6 minus 0.3t, we can take plus, we can keep plus here. or we can write it as plus of minus. Now it is in the form of v equal to u plus at, where u value 0.6 meter per second and a value minus 0.3 meter per second square. Because it is in the form of this, so without calculation, directly we can guess the values of u and a. So option B is correct. Next one, 13th question. If a scooter acquires a velocity of 36 km per hour in 10 seconds, just after its start, means initially it was at rest. Initially it was at rest. But in 10 seconds, it has acquired a velocity of 36 kmph, where kmph is not the SI unit, it is the general unit, to be converted into meter per second. So then, acceleration of scooter, how much? So u value 0, v value 36 kmph. We can convert into meter per second by multiplying with 5 by 18. 36 into 5 by 18. 18 2 times 36, 2 5 times 10 meter per second. T value, already they have given 10 meter per second. Now we know the formula of acceleration, which is v minus u by t, 10 minus 0 by 10, which is equal to 1 meter by second square. 1 minute, children. Next, children, we have 14th question. 14th question. One minute, children. We have 14th question. A train moving with a uniform acceleration crosses station A with a velocity of 108 km per hour and another station B with a velocity of 144 km per hour. So it is crossing station A with 108 km per hour speed or with velocity, and crossing station B with 144 kmph velocity. And the time taken for the train to travel from A to B is 20 minutes. Then the distance between two stations is how much? So initial velocity while crossing station A, the velocity is 108 kmph. It will be considered as initial velocity. If it is converted into meter per second, to be multiplied with the 5 by 18 to convert to meter per second. 18 6 times 108, 6 5 times 30. This will be the initial velocity of the train. While crossing B, its velocity is 144 kmph, which is considered as final velocity. If it is multiplied by 5 by 18, 18 how many times? 18 8 times 144, 8 5 times 40, we will get 40 meter per second, which is considered as final velocity. And the time they have given 20 minutes to reach from A to B. The distance from A to B is covered in 20 minutes as per the data. If it is converted into seconds, 20 into 60, 1200 seconds. So display distance between A to B, how much? That S value we have to find. We have the formula for A, acceleration, which is equal to v minus u by t, 40 minus 30 by 1200, 10 by 1200, 1 by 120 meter per second. This will be the acceleration, because directly if we know v, if we know u and t, we cannot find s directly, because we have two formulas for s. One is s equal to ut plus half at square, another one is v square minus u square equal to 2as. In both the equations, a is there, a is involved. So only with v, u, t, we cannot find s value. compulsorily we have to find a value also. So that's why we are calculating the acceleration first, which is equal to 1 by 120 meter per second. Now, by using this formula, s equal to ut plus half at square, by using this formula and by substituting these values, u30, t 1200, half, a 1 by 120, t square 1200 whole square, by substituting all values and after simplification, here 120 10 times 1200, 2 5 times 10, so 36,000 plus 6,000, 42,000 meter, which is equal to 42 kilometer. This is the distance between station A and station B. Option B is right. Next, 15th question. Given that s equal to 5t plus 8t square in SI unit, then the initial velocity and acceleration are how much? So we have s equal to, we have an expression s equal to 5t plus 8t square, but we have to write it in the form of s equal to ut plus half at square. In the place of ut we have 5t, it is okay, but 8t square to be written in the form of half at square, but there is no half here. So what we can do, we can multiply with 2, we can divide with 2. 2 by 2, 8t square we can write. 2 into 8, 16. We can write it as 1 by 2, 16t square. Without changing the value, by balancing the equation, we can write it as 1 by 2, 16t square. Now, if we compare them, in the place of u, we have 5. In the place of a, we have 16. So, u value 5 meter per second, a value 16 meter per second square. This is the answer. Okay, children, that's all for today. Remaining topic we can learn in our next video. So, thank you for watching our video, children. Please subscribe our channel and press the bell icon for receiving latest updates. You can also visit our website, children, www.aimstoday.in, for information regarding previous online classes, quizzes, worksheets, activities, English classes, coding skills. Thank you, children. Have a good day.